Okay, so we are starting our unit on space. Our essential question for today is, how does the relative position of the Earth and Sun affect seasons? So our learning target is 22. Explain and model how the different tilts of Earth impact seasonal changes. Okay, so let's first start off with some properties of Earth. Earth is a spherical shape due to the force of gravity. Gravity pulls everything in and makes that spherical shape. An axis is an imaginary vertical line that Earth spins around. That axis is what creates our rotation. Once around an axis is 1 day or 24 hours on Earth. A revolution is the orbit that the Earth takes around the Sun. That's our year, 365 days. It's an elliptical orbit. And our Earth also has what's called a magnetic field that protects against solar wind. So our Sun sends out a tremendous amount of electromagnetic radiation. These invisible lines that you see surrounding Earth are what we call our magnetic field. They were discovered by Van Allen, and that is a field that protects us against solar wind. Okay, so seasons. Our axis is tilted, and when we are tilted toward the Sun, we receive more direct sunlight than when we're tilted away from the Sun. We receive less direct sunlight. Seasons are not created by the distance between the Sun and the Earth. Earth is actually closer to the Sun in our winter and farther away from the Sun in the summer. What does create our seasons is our tilt. So let's take a look at this. Okay, so in June, we are tilted toward the Sun, so we receive more direct rays in the northern hemisphere. In the winter, we are tilted away from the Sun, so we receive less direct sunlight. Most of the sunlight that is received in December goes to the southern hemisphere. And just so you guys know, we are tilted at an axis of 23.5 degrees. This line right here, and I know I will not draw it very straight, is our axis. Okay, so when we are tilted toward the Sun, we're receiving, northern hemisphere is receiving direct sunlight. When we are tilted away from the Sun, the southern hemisphere receives that direct sunlight, and we receive indirect. Okay, so let's take a look at our tilt a little bit more. Okay, so this is going to show you, okay, right now, if this is our Sun and this is the Earth, we are tilted away from the Earth. So most of the direct sunlight is hitting the southern hemisphere. So we receive less direct sunlight, and so we are in winter. Fall. Okay, now we're in summer. The northern hemisphere is tilted toward the Sun, so we are receiving more direct sunlight. Now, to show us how this works, this is an app that you will be working with a lot. Right now, if you notice, there is no tilt. Okay, the Earth is revolving around an axis that is straight up and down. We call that zero angle, so that's no tilt. Okay, if you notice, over here, this is showing you sunlight angle. It doesn't change. If we go a little bit faster, okay, notice the sun's rays do not change at all. So when there is no tilt on the Earth, there are no seasons. You're going to have the same temperature the whole year in a certain area because the sunlight is not changing, the amount of sunlight. So look here at the temperature, mild. So you're going to have mild temperature all year. Now we are tilted at 23.5. So I'm going to move this as close as I can get to 23.5. Now what I want you to do is watch how the sun's angle changes. So I'm going to go slower. Well, I'm going to go a little bit faster, and I'm going to stop us right now. So the X's in the southern are in the northern hemisphere. If you notice right now, we are tilted away from the Sun. Okay, look at our Sun's angles. Okay, look at the temperature. It's cooler. Okay, so when we are tilted away, we receive less direct sunlight. So we receive what's called indirect sunlight. So that's why the northern hemisphere is in winter. So now we're going around. Look and notice the sunlight angle is changing. Okay, we're going to pause it there. So now we're tilted, the northern hemisphere is tilted toward the sun. So we're receiving more direct sunlight. If you can look right there, notice our temperature goes up. So that's why in the northern hemisphere, when we're tilted toward the sun, we are in summer. Okay, so now let's, so I'm going to play it one more time at our tilt. Watch how the angle changes when we get tilted farther away. We receive indirect sunlight, less direct. As we start tilting more toward the sun, we're receiving more direct. Okay, so now let's look if we're tilted more than 23.5. Okay, look how that changes the sunlight angle. Now we're receiving more direct sunlight, and look here, even less direct sunlight in the winter. Look how cold it gets. So when we tilt more than 23.5, we're going to get extreme seasons. It's going to be really warm in summer and really cold in the winter. Now we change that and we go less than 23.5, less than what we're tilted. We're going to get milder seasons. Okay, this is getting to where we're getting closer to straight up and down. So we're going to get milder seasons. So our summer will not be as warm and our winter will not be as cold. And then when we go to a tilt of 0 degrees, we're going to get the same season all year round. Okay, so hopefully that explains our tilt and how we receive indirect versus direct sunlight. Okay, a solstice is a day when the sun reaches its greatest distance north or south of the equator. That happens 2 times during the year. December 21st, December 22nd are the winter solstice in the northern hemisphere, and then the June 21st and 22nd is the summer solstice in the northern hemisphere. Those dates are reversed for the southern hemisphere. So December would be the southern hemisphere summer solstice, and June would be the winter. Okay, this is another link on our website that also shows you, okay, the tilt. So right now in January, we're tilted away from the Earth. Kind of just, you can move it around. And this is just another application to use. Okay, an equinox occurs when the sun is directly above the equator. That happens in our spring and our fall. So in spring, it's in March, and in the fall, it's in September. Okay, the last thing we're going to talk about is gravity. So gravity is the force that pulls everything into orbit around our sun. And so we're going to take a look at this. You're going to watch a little clip on satellites in orbit. So how do we get things in orbit around Earth? So you have to launch an object with enough force that it has enough speed so that it can escape our atmosphere and get into the pull of gravity so that it doesn't automatically pull it straight down to Earth. And that's what you're seeing here. So that's enough force to get into orbit. Okay, another thing we're going to look at is why do we have elliptical orbits? A circle is when you have one focus in the center, okay, and that creates the same distance from that focus, so that creates a circular orbit. However, we do not have a circular, we have an elliptical. Okay, that's when there's 2 focuses, the planet and the Earth. So we create an elliptical orbit. Notice the planet moves the fastest when it's closest to the sun. In the northern hemisphere, that's actually in the winter. Okay, so that concludes our notes on seasons. Again, if the link to the website that shows you the different tilts is on my website, you guys will be practicing with that. Not this one, sorry. This one. You will be practicing with that in class, but this is an excellent tool to kind of get to look at the difference between indirect and direct sunlight. It's an also good website to show how when we change the tilt, because you are going to have to know, well, that's our target. What happens when we change the tilt? So when it's at 0 degrees tilt, we have a mild season all year round. When we're at our 23.5 degree tilt, we'll need to know what happens. When do we have a summer, winter? When we go more than 23.5, okay, we've got more extreme seasons. When we're less than 23.5, we're milder seasons. So you are going to need to know what happens with the direct and indirect sunlight when we change our tilt.